Good day, students. In last video, we have discussed about the DMA, that is direct memory access, DMA controllers, how we can input output device can communicate with the memory without the interference of the processor. That thing we have discussed in the last video, that is DMA controller. The next topic and one of the most important topic of this unit is that bus arbitration that we are going to discuss in this video. First question arises why we need of this bus arbitration, and the second question is what is this bus arbitration. That first we need to answer them, then we will study how we can do this bus arbitration, what are different techniques to implement this bus arbitration. The first question that comes into mind when we are talking about bus arbitration is why we need that arbitration. As we all of us now know what is bus is a set of wires that is used to communicate between internally between the system, that is either between input output devices and memory or processor, whatever. It provides the internal communication within the computer, that is defined as a bus. Now, as we discussed in the last video, if there is a DMA, if let us suppose there is only one DMA and one processor, and both of them want the system bus at the same time, then there should be any process through which we can decide who will be the who will be having the control on the bus at that time. Either it will be processor or either it will be DMA. And let us suppose if it is not between the processor and the DMA, let us suppose within a single system you are having two DMA controllers for two different IO devices. You are having two DMA controllers and both of them want the control of the bus at the same time. Then how you will select to whom you need to give the control? That process by which you will going to select that who is going to take the control is named as arbitration. And because we are talking about system bus, we are naming it bus arbitration. It's like that. Let us suppose in India or any other many countries some election is going to happen or always. Then in election, what is the process? What you are doing in the election things? You will do the votings. People will do the votings, and depending upon the voting, the candidate will be selected. Okay, the voting is what? Voting is a process by which candidates will be. Result is what? Candidate has been selected. The same way, bus arbitration is what? Arbitration is a process by which, like a voting. Arbitration is a vote. If you analogy, if you want to find out in these two things, then arbitration is a process, like voting is a process through which candidate will be selected. For voting, candidate will be either CM or your whatever MP or MLA. Here, it will be a bus master. Bus master means who is having the control of the buses. Let us take one more example. Uh, Let us suppose we are having three devices, device 1, device 2 and device 3. And if we want to communicate between any two persons, or so what is there? Any one person need to start the communication. Then only communication will start. Let us suppose right now I am making this video to communicate with you. So first either I need to start or either you need to start. Then only we can start the communication between two peoples. Okay, so that is the case. Let us suppose for our sake, we are saying that initially device 1 will start the communication. Means device 1 will uh, start first to communicate with device 2 and device 3. Then we will say right now device 1 is the bus master. Who is going to start the process? That will be named as bus master. There is no other any terminology apart from that. We will be having only one terminology, that is bus master, and bus master will be who is going to initiate the process. Let us suppose now process has been initiated by device 1 and communication has started between device 1, device 2 and device 3. Let us suppose now after some time device 1 does not want to communicate with device 1 and 2, sorry, with 2 and 3. Device 1 does not want to communicate further. Communication not required from device 1. But still device 2 and device 3 want to continue their communication. Now we have to select any process that this bus mastership. Previously device 1 was the master, but now device 1 does not want to communicate, so he has left the things. now only two devices, device 2 and device 3, then how you will select who is going to be the bus master? Either device 2 is going to be bus master, or either device 3 is going to be bus master. Okay, that thing is named as bus arbitration. So that answers our question, what is bus arbitration? Okay, the process of selecting the bus master is named as bus arbitration, or simply it is the process by which the next device to become the bus master is selected. That process is named as bus arbitration. Normally, in our most of the computer systems, there are two approaches, or there are two, like voting is the process in India. Same way in computer systems, there are mainly two processes to do that, to select that bus mastership. One is named as centralized arbitration, and second one is named as distributed arbitration. So we are going to discuss both of these two approaches, that is centralized arbitration and distributed arbitration, in detail. So let's start with the first, centralized arbitration. This centralized arbitration can be, one second, can be understand with the help of this diagram. You can see it is a simple block diagram of centralized arbitration. There will be a processor, and let us suppose the condition is like that: we are having two DMA controllers, DMA controller 1, DMA controller 2, and at any time, any of how you will select that, either DMA controller 1 will be given the bus mastership, or either DMA controller 2 will be given the bus mastership. So what will happen? Let us suppose DMA controller 2 wants the bus mastership. What is the case? DMA 2 wants the mastership, or simply wants the control over the system bus. That is the mean. So what will happen? First, it will send the, as we already discussed in last video, it will send the bus request. So it will send the bus request through this line. Okay, it is a logical OR line. Both the DMA can be, will use the same line. It will send the bus request. Then what will happen in the second step? Processor will check it is genuine or not, and depending upon that, processor will send bus grant signal. That is logical high. So bus processor will send BG signal. It will send only BG1, because it is a it is somewhat like a daisy chain that we have discussed in earlier video. It is, the arrangement is somewhat like a daisy chain. So processor will send the bus grant signal to DMA controller 1 first. Now DMA controller 1 will check it has requested for bus or not. If it has requested for the bus, then it will take the control. It won't go to DMA controller 2, it will take the control. Okay, that means priority is given to DMA controller 1 because it comes first in the line. But let us suppose, as in our case, DMA 2 has required the mastership, has requested the thing. So what we'll do, this DMA controller 1, that is DMA 1, will deactivate BG1 because it has not requested for the bus, and activate BG2. It will deactivate this BG1 and it will activate BG2. That means it will transfer this bus grant request from itself to DMA controller 2. It will send that one. Now as DMA controller has requested for that, it got the grant, so it will take the control. DMA2 will control the, DMA2 will take the control. Okay, now you say, okay sir, task has been over, DMA2 ask for the request, DMA2 have taken the control. Then if you will see, we have discussed about all those things, but till now this bus BG, this is what? Bus BG line. What is the meaning of why this bus BG line is there? So there is a separate dedicated line for bus BG. This lines tell bus is BG or not. Okay, processor has given the grant to the DMA controller. But let us suppose right now some input output device already has having a communication through that bus. So first that communication need to complete. That's why this bus BG line should be there. So what will do, DMA controller will check for this bus as soon as it got the grant, bus grant, it will check for this bus BG line. If this bus BG line is low, that as it is, you can see it is a low line. Okay, bar is there. If it is low, that means it will take the control of the bus and it will start doing its process. But if bus BG line is at high level or at logic 1, it will wait for what? Unless this bus BG line will become again logic 0. Then as soon as this bus BG line will become 0, DMA will take the control after BBG line becomes active low or at logic 0, it will take the control and it will start its working. Okay, so this will be the process in centralized arbitration. You will say, sir, why it is named as centralized arbitration? Because here processor is involved in this thing, and all the arbitration that either DMA controller 1 will take the bus or 2 or will take, or if there can be 3 for any year, all will be controlled by the processor centrally. That's why this process is named as centralized arbitration. Okay, so this is all about centralized arbitration, and what we have discussed in these steps 1, 2, 3, 4, this also can be understand with the help of this timing diagram. You can see bus request. We are taking again the same example that DMA2 have requested for the thing. So first you can see it is active low signal, BR bar is there. So when it will become low, it will get activated. So, at this instant, your DMA has requested the signal. Okay, so after some time, processor will give the bus grant signal BG1. As it is not active low, it will become high. Now DMA controller will check that it has requested for the bus or not. So it will take some time. After that time, because it has not requested, it will activate the BG2 signal. So that's why after some time BG2 signal will be activated. As soon as BG2 signal get activated, DMA controller go to the access of the bus. But when DMA controller will start the work, when this bus BG lines will become low, because this is also active low line. So we have to check for this BG line at it is already high. Once it become low, at this instant it will become low. Okay, so you can see DMA controller have started the work. Okay, so it will do its work. So this is only just like this process is going on, same way this is going on. Okay, so this is how you can select the master using the centralized arbitration. Okay, another method that is used in computer system is distributed arbitration. In distributed arbitration method, there is no processor is not involved in selecting the mastership. Okay, what is happening, all DMAs or all the devices will communicate with each other and they will decide who will be going to take the bus mastership. There is no role of processor, there is no any centralized unit to select the bus master. What will happen, it's like that, uh, let us suppose instead of doing the voting we are having four peoples, and we don't have any voting process and all those, and other people will not vote for those four peoples, and they will select by their self, I will be the CM or whatever. Let us suppose from your constituency MLA elections are going on or MP elections are going on and you are going for voting. Instead of you are going for voting, all the contenders who have uh, who are asking for vote for that MLA position, they will decide by themselves that I will be the MLA. It's like that. So in distributed system, there is no requirement of the processor, or there is no any centralized system. All the candidate like DMA1, DMA2, or DMA3, they will decide, they will communicate with each other and they will decide who will take the bus mastership. So, uh, for the for example point of view, let us suppose it is a 4-bit distributed arbitration. That means at a time only 16 devices can communicate with each other in this kind of system. So what will happen, there will be 4 bit identification number on these lines. What will every device every device will be having a unique 4-bit ID number identification. Every device in this kind of arbitration will be having a unique 4-bit ID. So what gonna happen if any device, let us suppose we are having two devices A and B. A is having his ID as 010 and B is having its ID as 0110. That is, this is 5 or this is 6. Okay, for decimal point of view. Let us suppose A and B, both of them want to access the system bus. What they will do? First, they will send a start arbitration signal. So, like there is a bus request signal in a centralized distribution, we are having here start arbitration. So this is like a bus request. Whatever device want the system bus, they will give a signal to the start arbitration. You can see this is for a device. They will send their signal to the bus start arbitration. If B is also there, he will give the signal to the start arbitration. As soon as this start arbitration signal will get, this arbitration process will start. In the process, what will happen? These 0101, this 4-bit ID number will be sent to these. Like here you can see, it will be sent to these 4 lines, RB0 to RB3. This is your LSB and this will be your MSB. This will be MSB and then it will be LSB. Like if it is 0101, it will be like 0 1 0. Let us take another color. Yeah, it will be like 0 1 0 and 1. And for B, let us suppose we will take another color. For B, it will be 0110. So it will be like, sorry. Just a second. For A, it will be 0 1 0 1 because it is MSB. So this is your MSB and this is your LSB. This is your MSB and this is going to be your LSB. And for B, it is going to be 0110. For B, let us suppose it will be 0, it will be 1, it will be 1, and again it will be 0. So how it will be selected that which is going to be the bus master, which is having the higher ID number. Like for in this case, A is 5, B is 6, which is having higher ID number? B definitely. So B will get the mastership. So here what we'll do, they will comparison will be done because uh, if maximum it will be 0111, if MSB will consider as a first. So first MSB will be compared. If MSB is equal, then it will go to next bit. This is also equal, then it will go to next bit, which is having high. Either 0 1, 1 will be high, so that particular bus will be given, particular device will be given the mastership. In distributed arbitration, in that way, you are going to select which will be having the control over the bus, who will be the next bus master. This is distributed arbitration. So these are two different kinds of arbitration. One is centralized and distributed. Another one is distributed. This bus arbitration is one of the important topic from examination point of view. Either it is whatever the pattern. Okay, so this is going to be one of the important question. Normally questions comes like define bus arbitration and explain both two different techniques of arbitration, that is centralized and distributed arbitration. So I hope this is clear what is bus arbitration and how we can implement this arbitration. Another small topic, is multi-level bus architecture. What is multi-level bus architecture? Now we know bus is there. Bus is required for any kind of communication inside the computer system. Either it is between the processor and input output devices, either it is between the processor and memory, whatever is there, but we require a bus to communicate, to provide a communication. There can be two kind of bus architecture. Either it can be a single level, one level, or single level, or either it can be a multi-level. Single level means there will be only one bus and all the communication will be done through that particular bus only, that we have discussed till now. That was the case of a single bus architecture. But there can be a multi-level bus architecture. Multi-level bus architecture means we can have two or the three levels of buses, dedicated buses for higher speed point of view. Let us suppose this is a two level bus architecture. One is their processor local bus and one is their peripheral bus. Processor local bus are normally high speed, wide, most frequent communication, means most of the communication will be between the processor. That's why processor local bus will be like a most frequent communication will be there. It will connect all the processor, cache memory, main memory, DMA controllers, all will be there through the processor local bus. Another kind of bus can be there, that is a that's another level is the peripheral bus. So peripheral bus is all the peripheral devices like IO devices can communicate with each other. For that kind of that purpose, we'll be having that peripheral bus. If it there is a multi-level bus architecture, then there should be any way to communicate between two buses. Here, for example, in our case, there are two buses. One is processor local bus, another is the peripheral bus. To provide a communication between two buses, we have a thing that is named as bridge. So bridge is nothing. Okay, it is a simple single purpose processor whose purpose is to just provide a communication between two different kind of buses. In our case, it is a processor local bus and peripheral bus. So this is all about, means a small question can come in exams. What is multi-level bus architecture and what is its requirement? So you can, with the help of this diagram, you can easily explain that. Even in exam, I think in unit first already we have this. You have know what are bus architecture. There can be a single level bus architecture or there can be a multi-level bus architecture. That is it for this video. In next video, we are going to study about input output interface. As we have discussed in last videos, that if input output device want to communicate, want a connection with the bus, in between them there should be some kind of driver, there should be some kind of control circuitry, or you can say there should be kind of some interface, okay, which is required for this kind of communications. So in the next video, we will be discussing about IO interfaces. There are two kind of interface, port, serial port and parallel port. All those things we will be discussing in the next video. Thank you.